Okay, guys, we're going to use the identity and inverse to write equivalent expressions today. I want you to understand the identity properties of 0 and the identity property of 1 and how those opposites and reciprocals help us write equivalent expressions. So we have in the opening exercise, we have a few problems here. Let's go all the way to E. Give these a try. Think about what we've covered in other lessons in your previous knowledge. Think about your definitions of opposites and reciprocals to give you some guidance. I'd like you to pause and try these right now. Okay, now that you've attempted those, let's see how you did. So if we think about in the morning, Harrison checked a temperature outside to find that it was negative 12 degrees Fahrenheit. It's pretty cold. Later in the afternoon, the temperature rose 12 degrees Fahrenheit. Write an expression representing the temperature change. So notice we want an expression, then tell what was the afternoon temperature. So an expression being that mathematical sentence without an equal sign. If it started at negative 12 degrees Fahrenheit, and then it rose 12, that means we're going to add 12. So our expression is listed here. What was the afternoon temperature? The afternoon temperature was, well, those are additive inverses of each other. Those are opposites, so it was 0 degrees Fahrenheit. Let's rewrite these problems. Rewrite your subtraction as adding the inverse for the following problems, then find the sum. Find the sum because we're changing it to addition. So 2 minus 2 is the same thing as 2 plus negative 2. You add the opposite. And if you go to the right 2 units on the number line, and then you go to the left 2 units on the number line, we end up at 0. Negative 4 minus negative 4. Rather than subtracting, let's add the opposite. The opposite of negative 4 is positive 4. Notice how I'm rewriting it. If you go to the left 4 units on the number line and you go to the right 4 units, again you get 0. The difference of 5 and 5. Difference is a vocabulary word that means subtraction. So the difference of 5 minus 5. I know that you know 5 minus 5 is 0. But if your job is to rewrite it using the additive inverse, then you should write 5, not subtraction, but addition, and take the opposite of 5, which is negative 5. And we can put parentheses there to make it more clear. 5 plus negative 5 gives us 0. Well, what does that mean for variables? Can we do the same thing? Absolutely. If we have g minus g, then adding the opposite would be g plus negative g. Again, parentheses to make it clear. If we're adding 2 numbers that are the same with opposite signs, we get a sum of 0. What pattern do you notice in these two? Yeah, the sum of a number and its opposite is always going to give us 0. That's what the next question is asking here. We could have written the sum of a number and its additive inverse will always equal 0. You can write that here if you want to. These are your notes. They're meant to help you and guide you through problems later. So let's add or subtract here. Let's think about our rules from before, or think about some new rules that you might want to that can help make math a little bit easier. 16 plus 0. Yeah. So when we add 0, we got the same number. 0 minus 7. Well, we learned that to minus 7 is the same thing as 0 plus negative 7. So when we added 0 here, nothing changed. When we add 0 here, nothing changes. Negative 4 plus 0. When we add nothing, nothing changes. Well, what about if we have a variable in there? 0 plus d will always equal whatever the value of d is. So what patterns did you notice here? Yeah, the sum of any number and 0 will always equal that number. That has a name to it. Anybody know? Yeah, that's the additive identity. Whenever you add 0 and always get that number, it's your additive identity, property of 0. Your younger sibling runs up to you and excitedly exclaims, "I'm thinking of a number. If I add it to the number 2 10 times, that is 2 plus my number plus my number plus my number and so on, then the answer is 2. What is my number?" You almost immediately answer 0. But are you sure? Can you find a different number other than 0 that has the same property? If not, can you justify that your answer is the only correct answer? Think about that for a second. Is there any other number that you could add over and over again? No, there isn't going to be any other number. On a number line, 2 can be represented as a directed line segment that starts at 0 and it goes to the right 2. It has a line segment, it has a length of 2. Adding any other number, whether it be positive or negative, is going to cause us to go past the value of 2 here. It says that we have to justify. So if we used a number line here, if this is 0 and we're at, here's 1, 2, any kind of change, remember that vector, any kind of change this way would have to be written as like 2 plus v. So if you add v again, the new sum takes you further away from 0, which is not going to give you the same value. And it says we're adding the same number over and over, so it's going to give us a value further away from 0. So here's my justification. Okay, let's turn the page over. It says example 1. So just keep in mind that what we just discussed, understanding opposites, additive inverse, the identity property of 0, the additive identity property of 0, meaning that we can add 0 and it's not going to change the value of the number. Those things can help you understand, it can help you evaluate expressions later on. So let's go to example 1. It says write the sum. So we know we're adding it. Then write the equivalent expression by collecting all the terms and removing parentheses. So let's write this as an addition problem. 2x and, our next part is an expression, negative 2x plus 3. So we're adding. We could use the associative property since it's all addition, and we could change that order like this. What is 2x plus negative 2x? What did you learn about adding the opposites? Well, that gives you 0. And we know that 0 plus 3 is 3. So we used the associative property and then the additive inverse property, since they canceled each other out and gave us 0. Let's try the next one, 2x minus 7, and the opposite of 2x. Here's 2x minus 7, and because we were told to add the opposite of 2x. Well, what's the opposite of 2x? Negative 2x. So, first of all, I see that they both have these x's, so I could use the commutative property and change the order if I wanted to. Put that 2x and move the 7 to the back. I could use the additive inverse property here to see when I'm adding a number and its opposite. Those are going to cancel each other out, so I'm going to end up with 0. And 0 plus negative 7 gives me negative 7. The additive identity property of 0 here. The opposite of 5x minus 1. Well, to find the opposite of that, I multiply it by negative 1 and 5x. So first, let's go ahead and find the opposite by applying the distributive property. That's what number here? 1. And even though I know it's there, I like to write it. Negative 1 times 5x is negative 5x. And negative 1 times negative 1 gives me positive 1. So now I've removed the parentheses by applying the distributive property. We could use the commutative property now and change the order to get those x's together. And here we have additive inverses. Since they're additive inverses, they're going to give us 0 together. And then we know the additive identity property of 0 states anything when we add it to 0 or add 0 to it gives us that same number. Noticing those different properties of numbers helps us solve problems or simplify problems more efficiently. Okay, so the next part says, with a partner, take turns alternating roles as the writer and the speaker. The speaker verbalizes how to write the sum and the properties that justify each step, as the writer writes what's being spoken out without any input. At the end of the problem, discuss in pairs the resulting equivalent expressions. So you're supposed to write the sum and then write equivalent expressions by collecting like terms and removing the parentheses when possible, just like we did up here. But this works really well if you follow the directions. If one person chooses to be the writer and the other person chooses to be the speaker, it makes you think about your steps and why you do them a little more. So if you want to pause and do this with a partner, you may do that. So what you should have done here is written negative 4. We're writing it as a sum, so we're adding 4b plus 4. Now we're going to notice that those are both constants of 4. They have a digit of 4, even though they're opposite of one another. So I would use the commutative property and change the order of that problem. Notice these two are additive inverses of each other, so those would give you 0. And the additive identity property of 0 states that when you add anything to 0, you're going to get that same value. So it simplifies to 4b. 3x and 1 minus 3x. I'm just going to rewrite the problem because I know it says and here, but I need it to be addition down here. I am going to change the order. Oh, I see some subtraction here, so let's do, rather than subtracting, let's do additive inverse. So I'll rewrite this as, rather than 1 minus 3x, that's 1 plus negative 3x. Additive inverses. Okay, so now I'll use the commutative property. I'll change this order up since it's all addition. I can do that. When it was subtraction, I could not do that. So I'm going to switch the order of these two. Plus negative 3x and 1. Notice these two are additive inverses, so together they're going to give us 0. 0 and 1 give us 1. I think this is a lot simpler to solve than this. A few more you should have tried with your partner. The opposite of 4x. Well, here's 4x, so the opposite of that would be negative 4x and negative 5 plus 4x. Okay, since it's addition, I can change the order, the commutative property, with no problems. This is the additive inverses, so they give us 0. And that is the additive identity property of 0. Because if you add 0, it doesn't change anybody's value. Okay, here we have the opposite of negative 10t. What is the opposite of negative 10t? Well, let's find the opposite by multiplying it by negative 1. Negative 1 times negative 10t gives us positive 10t. The rest of our problem up here was and t minus 10t. Okay, we see subtraction, so let's get rid of that subtraction by adding the opposite here being negative 10t. And again, we could change that order as necessary, the commutative property. So I would do 10t plus negative 10t plus t. Those are opposites, which give us 0, and 0 plus t gives us t. Rather than filling it in, doing all this multiplication, it simplifies to just give you the value of t. The opposite of negative 7 minus 4v. Here's how we find the opposite, by multiplying it by negative 1 and negative 4v. So I'll go ahead and find the opposites by doing the distributive property. Negative 1 times negative 7 gives me positive 7, and negative 1 times negative 4v gives me positive 4v. I'll bring the rest of the problem down. Notice these two are additive inverses, so they give us 0, and 7 plus 0 gives us 7. Okay, so let's go on to some multiplication. Remember, whenever you're, remember what we learned about the multiplicative inverse. We've covered that in an earlier, where did we find it? Right here. Remember, but multiplying by the opposite gives us a sum of 1. Gives us a product of 1. We did that in lesson 2. So we're going to apply that same knowledge here. Here, 3/4 times 4/3. These you should be able to pause and do by yourself. When we multiply fractions, we go straight across. So we're multiplying by the opposite. We know what it's going to give us. We know that it's going to give us 1, but I can prove it to you if you multiply straight across. 3 times 4 is 12, and 4 times 3 is 12, which gives us 1. 4 times 1/4, that's multiplying by the opposite, or the reciprocal. So we know it's going to give us 1. 1/9 times its opposite. The opposite of 1/9 is 9/1, so that gives us 1. These are all the multiplicative inverse. Is this the opposite? Negative 1/3 times negative 3. Remember, when we're talking about multiplicative inverse, we're flipping that fraction. So is 3 the opposite of 1/3? Yes, our sign stays the same here. A negative times a negative is a positive. And again, sign stays the same. 6/5 times 5/6, 30 over 30. We know it gives us 1. So remember that the multiplicative inverse can be applied here when you find that reciprocal. That's a good vocabulary word. There's not going to be a change of the sign. There's only going to be that flipping of the fraction. The sign is going to stay the same. So we know the product of a number and its multiplicative inverse always equals 1. Earlier we saw that 0 is a special number because it's the only number that when added to another number, the result is that same number. Think about why 1 is so special. 1 is going to be the only number that when you multiply it by another number, we get that number. It keeps its identity. So this property of 1 is special because the multiplicative identity property of 1 is the same as the additive identity property of 0. We always get that same number. Okay, so let's see what we could do here. The multiplicative inverse of 1/5, and so we know that we're multiplying. But what is the multiplicative inverse of 1/5? 5 times 2x minus 1/5, because it says the multiplicative inverse of 1/5. So I'm not going to use 1/5. I use the multiplicative inverse of 5. Write the product. So we did that. And then write the expression in standard form by removing parentheses and combining like terms. Justify each step. So let's use the distributive property. Let's hand out this multiplication of 5. What is 5 times 2x? 10x. And what is 5 times negative 1/5? Well, what is 5? Positive times a negative is a negative. And 5 times its multiplicative inverse gives us 1. So we get 10x minus 1. Let's do the multiplicative inverse of 2, which is, what's the reciprocal? 1/2, and 2x plus 4. Just because fractions are in there shouldn't scare you. We do the same thing. Let's hand out that multiplication of 1/2 to everything in parentheses. What is 1/2 of 2x? Well, that's going to be 1x. And what is 1/2 of 4? 2. But we know that multiplying by 1 doesn't change anything. That's the multiplicative identity property. So we don't need to write it. We get x plus 2. And letter C, the multiplicative inverse of 1 over 3x plus 5 and 1/3. Now that might look a little bit complicated, but you should feel comfortable with it. Watch. The multiplicative inverse just means the reciprocal. So if we flip this, that's 3x plus 5 over 1. Putting it over 1, dividing by 1 doesn't change anything, so that part's not even necessary. 3x plus 5 and 1/3. We're used to seeing that in front, so we could do that. 1/3. We could change that order, right? Commutative property. And now we can do your distributive property. 1/3 of 3x is 1x. And 1/3 times 5 gives me 5/3. Does this coefficient of 1 do anything? No. Multiplying by 1, the multiplicative property, identity property of 1 means it doesn't change anything. So I would write x plus 5/3. Okay. Y'all do that speaker and writer jobs that you did earlier. one of you tell the other person what to do, and the other person has to be silent and just writing. This way you're thinking about why you're doing things and what makes sense, and it makes you think about the process more in depth. So pause and do that. Okay, so we want the reciprocal of 3. So flip that 3. 3 over 1 is now 1/3. And you're writing it as a product, so we're doing multiplication. Negative 6y minus 3x. Okay, now remember, we're doing multiplication here, so let's hand out that 1/3 times negative 6y. 1/3 of negative 6, a positive times a negative is a negative. 1/3 of 6 is 2y. Hand out that 1/3 to negative 3x. A third of negative 3 is negative 1. Remember the multiplicative identity property of 1. This doesn't change anything, so we would write negative 2y minus x. The multiplicative inverse of 4 and 4h minus 20. Multiplicative inverse is just a fancy word for reciprocal. The multiplicative inverse of 4 is 1/4 and 4h minus 20. Let's get rid of parentheses, combine like terms. 1/4 of 4h. If you break 4 into 4 pieces, you get 1h. And a positive times a negative is a negative. 1/4 of 20 is 5. What do you think we're going to write as our final answer? H minus 5. Multiplicative identity property of 1. And let's throw some fractions in there because I know how much I love those. The multiplicative inverse of negative 1/6. Remember, your sign stays the same, but rather than 1/6, it becomes 6/1. And 2 minus 1/6 j. Okay, let's make this a little simpler. Is this part necessary? No. That's negative 6. Okay, now you can hand out that multiplication. Negative 6 times 2 is negative 12, and negative 6 times negative 1/6 j. A negative times a negative is a positive, and 1/6 of 6 is 1. Again, drop that coefficient, not necessary. Negative 12 plus j. Okay, you have a problem set. Try these by yourself. Think about what's happening in each one, why we can do that. Remember, when your order changes, that's the commutative property. When your sum gives you a 0 here, that's the additive inverse property. Use your notes. Go back in the video as necessary. You have 1, 2, and 3, as well as 4 on that side.